Hi, how's it going today? Good morning. Hopefully, you can all hear me. If you can't, I assume it will be terribly obvious really fast when people start asking what's going on, and I just continue to plow ahead with it. How's everyone doing today? The sun just came out up here in Massachusetts, which is absolutely nice and gorgeous. And now I'm going to idiot check myself and make sure I can actually see this mic moving. Hello, check one, two, three. Looks like we're good. Yep. All right, so let's go ahead and get started today. Thank you, Adam. It's good to see your face too, even if it is the default YouTube chat emblem. So, today is kind of an audible from what we had planned. I say we as if there's some great behind the scenes crew working on this. It's just me in my dining room. So originally today was going to be a kind of introduction to D3 from the point of view of watch out and what that transition's like, what those two kind of work together as. We're going to put that on hold though. Some of us may be following along and playing along with Disguise doing their pre-productions workflow class, which grew out of the specialist workflow class, which is one of my favorites that they teach. And there was a project that they skipped yesterday just due to time. And so I'm going to do a riff on it, which I actually have from when I was teaching specialist workflow, and is a really interesting dive into kind of understanding UVs and looking at the difference between a UV optimized more for LED output as opposed to one optimized for projection output. So let's go ahead and let's dive into that. So here we have my desktop. This is me working out numbers. These numbers will be important later on, not yet. I'm going to pop into this array project. So we're doing this in Blender. Blender is my favorite. I'm down with the open source movement, real big fan of it. And also, Blender is just surprisingly powerful, it turns out. So, here we have the Blender interface. Let's go to default. So we have two of these me strip arrays of pixels. So these are Barco me strips. Each one is 112 pixels long and 1 pixel wide. So we've got 10 of them per each. We're going to look at two different ways to unwrap this. So let's go ahead and I need to bring up my notes so that I can see them still. Great. So let's look first at this left one, which we're going to do a variety of two riffs on the same way of unwrapping it, which are not how I would suggest doing this, but it's a good exploration and it's kind of interesting to go down this rabbit hole. So we're going to go into the UV editing. Tab to select it. And we can unwrap it using the U key to open up the unwrap menu. So UV unwrapping, what we're doing is basically telling 3D software this is where we apply pixels to. And we're going to use the project from view method. So projecting from view is similar to a perspective map in D3 basically. We're going to use a camera shot. So if we hit project from view, what we'll get is that there. And already we've actually made a mistake, which those of you following along at home are probably screaming at me about already. Let's take a look and notice how some of these are longer than the others. That's because I'm not actually perfectly flat. If we're going to project from view for something that's perfectly flat like this, well, then we definitely want to be flat onto it. So on my number pad, I'm going to go ahead and hit 1, which is going to give me the front ortho view. And let's try that UV unwrap one more time. Project from view, much better. Now it's symmetrical, just like it's going to be in the real world. Turns out the me strips are all going to be the same size. Now looking at this UV, this is our full UV space. UV space is a 0 to 1 optimized area. We're not using this very effectively right now. So the next step we're going to do is optimize this UV for inside for use inside any of our 3D packages. So I've got the entire UV selected. I'm just going to click and drag it down to the corner. And down here under UV, I'm going to make sure that constrained to image bounds is on. And what that means is as I scale it or as I try and move it, notice how I can't get outside the 0 to 1 UV space. That's what I want, because when I hit scale, S key for scale, and just size it up, it perfectly fills, which is great. There's a slightly easier way to do this, which I'm going to show you. So we could either clear that UV by typing in, we hit spacebar. The way I have Blender set up is spacebar brings up a search for tools. So I could put in clear UV. But instead, what we're actually going to do is just re-unwrap it. And we're going to project from view bounds, because what we'll see is no difference. And that's exactly what we want, because the project from bounds basically optimized the mesh I have for the UV space. So it took a step out of that normalization, which is nice that we don't have to worry about it. So now this array is all set up. We can export it out. So I'm going to go here to File, Export, and D3 only accepts OBJs for content. So we're going to select the wavefront OBJ. And now we have to stick into place. So I'm going to go, I favorited my D3 projects folder here. And this will go into chat with chet 005 in the mesh folder. And what we're going to call this is array projected. This is our projected based array. So we're going to also come down here under operator presets and use the disguise preset that I have built, which is going to output just my selection. So whatever mesh I'm working with, it will include the UVs, it will triangulate the faces. When it comes to meshes, for working in content templates, non-triangulated faces are easier for people. However, when it comes to a computer optimizing and playing back on those meshes, we want them triangulated. In this case, we're going to triangulate it because it's the output. Scale is going to be 1, negative Z forward, and Y up. That's how 3D coordinates are set up in disguise, if we remember. So I'm just going to go ahead, click Export OBJ. And if we come over here to D3 projects, chat, objects, mesh, we have array projected, just like we wanted it to be. So let's go ahead and let's open D3 Manager now. And let's start this project up. It's really interesting. So I'm running the actual YouTube page on my... So first things first, I'm going to go ahead and projectors, we don't need our projector, and projection surfaces, we don't need our projection surface. I'm going to make a new LED screen, and that LED screen I'm going to call array projected. Now for its mesh, I'm going to choose my projected mesh array. And that's exactly what we think it should be. What should this resolution be is a good question. And I'm really glad that you asked that question. So the resolution of this is going to be based off of the overall size of the object, since the UV takes up only slivers of it. So basically what we want to do is figure out what the pixels per meter is on this entire mesh, and then use that to calculate what our final resolution is going to be. So in this case, over here to, I happen to search for the Barco Me strip on the Google, And it tells me some interesting things down here under the technical specifications. The pixel pitch is 13.25 millimeters, and the length is 1484 millimeters. So if we bring up our handy dandy calculator, there we go. So we can use the pixel pitch and that length to figure out what the actual resolution is going to be of one Barco Mi strip. So 1484 divided by 13.25 will give us 112. There's 112 pixels per each one. That's not useful with this UV unwrap. It's more useful for us to know in the future because, spoiler alert, we're going to need that information later. So I need to figure out what the pixels per meter are. Well, I can figure it out simply by taking 1,000 millimeters, 1 millimeter, and dividing that by 13.25, and that gives us 75.47 pixels per meter. So back here in D3, if we look in this array, we can actually figure out what the total size is of the mesh in the X direction and the Y direction. So the resolution in the X is going to be 4.61301 times that number that we came up with here, that 75.47. So 75.47, hit enter, that's going to give us 348.14. I'm going to go ahead and round this up. I don't like working in odd number or fractional pixels. Some programs can't handle it at all. Fractional pixels aren't a thing. So we're going to go ahead and round this to 350. And we're going to do the same thing here for the height, 4.96859 times 75.47. 75.47 gives us 376. So you can see this isn't a very big resolution. Substantially under an HD. So I'm not worried about that so much from an optimization standpoint. And let's go ahead and let's throw a radar layer to demonstrate something on it. So see how we get this radar layer that goes nice across all of it? That's a great effect that we may want in the future. However, what if I want the radar layer to grow from the center out? That's much harder to do in D3 because I don't have a really clever way to handle it built in. The next way we look at will have that clever way. But now we can see that's going across, and let's go ahead and let's put a video layer just so that we have some content on it. We'll use just George, so we'll have pieces of George's face. Move this down in layer order so we have that on top. And let's look at this in the feed. This is what that array's UV template looks like now. So if we wanted to patch that, it would just be a matter of patching it to whatever outputs. That being said, there's something that's really drastically bad about this. And that's going to be the looks that you get from your LED technician when you tell them how you've gone ahead and patched this. So let me jump out of D3 because D3 is really not enjoying running Blender and this at the same time. So back in Blender, here is our optimized UV. And look at this strip, this strip, this strip, this strip. Look at those angles. Those angles are super problematic from an LED patching point of view. When we work in the LED world, we're thinking in right angles, basically exclusively. trying to patch something like this would be an absolute nightmare and frankly not possible for most things. So this is why this is not a really helpful UV template for a me-strip array like this. Mind you, if I was projecting on it, this would work fine. Great. The projector sees the pieces of the mesh that it's going to project onto. I've got the pieces for me to quick cal. Great. I don't need to do it the way I'm going to demonstrate, but you can because of the advantages you get from the radar layer. It really depends on how your content team wants to work with things. So let's go ahead and let's take a look at this one now. So to unwrap this one, we're going to use a different technique. So we're going to go back into edit mode, UV, and this time we're going to use a light map pack. These don't really matter. We're just going to use the defaults for it. Let me actually select all that mesh. There we go. Unwrap light map pack. We can use the defaults. Click OK. And now we have one box for each face. And you can see here, if we look down at the bottom, we're in face select. So as I select one, it lights up. So what we're going to do as our next step is come down here under UV, make sure to turn off constrain to image bound, and I'm going to line all of these up here at the top. Here's our 1 o'clock position. This is going to drive people crazy because I'm swiftly going to forget where everything is. 3 o'clock position. Is this 4? 4 o'clock position. And we're just going to continue our way around this clock. Eight. 9. And 10. So you'll notice that I laid it out so that 1 o'clock is the first. This is entirely user preference. If I wanted to, I could shift around this order by just grabbing this, moving it back here. Same thing. And we'll go ahead and do that since I've already made that move. So the next step is I want to actually nicely line all of these up because you can see here, this is a pretty abysmal lineup. I'm not terribly good with my mouse. So down here, we've got this nice snap tool. So if I click the snap tool on, now I can select my first and just drag it over and it will snap to the next. So you can take this too far and it will snap on top of things. So be careful on that. But now we have them all together. I'm going to click B, bring up my bounding box, select them all, and then S to scale, and scale them down so that they'll fit within my UV space. Right like that. So now I'm going to turn the snap off because I don't need it snapping anymore and select all of these and drag them just in the middle right here really quickly while I come back down to my UV tools and turn back on constrain to image bound so I can bring these down to the bottom left corner. So you see this tool here, this is where my pivot and scaling point is. I have left it the 2D cursor, which is at the bottom left corner, the 0, 0 point of my UV. So now I can select these all, hit S for scale, and scale them up to fill the UV space. If you're looking at my mouse, you may have noticed this really nifty thing that Blender does. When you hit one edge of the screen, it just comes back around to the far edge. I really like that, especially when I have to do this random scale up. So now we've optimized the UV space for each of these. We've got our 10 me strips across in order with no empty space in the UV. Now there's just one last thing we're going to do before we export this out. I'm going to switch myself in the vertex select, make my bounding box, and select my top vertices, because one of these is not like the other. And when this project was set up, what I'm pretty sure happened is they copied and pasted the top and the bottom and didn't flip it. So all we're going to do is flip it to UV. Let's go ahead and switch back to face mode and select that bottom one. And this time we can choose our pivot point to be the individual origin. We're going to hit rotate R, 180, and enter. So now if we go back into our vertex select, bounding box, select all these, look, they're all on the outside. Much better. So let's go ahead and let's export this mesh. File, let's select all of it to be safe. File, export, wavefront OBJ. This is going to be array light map pack. It remembers where I saved it, so we're just going to go ahead and export that OBJ into the same place, making sure that we are using our disguise preset, which we are here. Perfect, perfect. Go ahead and export OBJ, and you're done. So it's going to save this. It's saved. Go ahead and close it. And in D3, let's hop back into chat with Chet, shall we? And now we wait for it to load, and I sip my coffee, which has slowly been getting cold this whole time. Array, just like we built it before. So now, let's go ahead. I'm just going to put a split here just so we have a different part of the timeline to look at. Stage, LED, array, light map pack. Gives us the default mesh. We're going to go ahead and choose the array light map pack, and it pops into the same place. So they look the same, great. Now we have to figure out what the resolution of the light map pack is going to be. And let's think back to what we set up previous. Well, it's going to be 10 across. So a cross resolution is going to be 10 because there's only one per bar. And its height resolution, we did that math earlier because I was tricksy about it, 112. Great. So let's make that same radar layer that we made earlier. Radar. And great, we have it just chasing around in a nice clock form like that. But if we change our direction from horizontal to vertical, we achieve that look that I was talking about earlier, being able to chase in and out of an object exactly like we want. And so yeah, if we want to switch that to be in opposite direction, 128, we can grow out of it just as easy. Great for us to work with. More optimized UV, though in this case it's not a big worry because we're at a smaller range. But what if you want to, say, do the same thing that we have here from the radar, of a radar across all of this? Well, that's where D3 has some nifty things to help us out. Up here, we're going to make a new mapping, and we'll call this light map pack para. Its type is going to be parallel. And you may have already guessed where this is going. For screens, we'll go ahead and we'll put in our array light map pack. I'm going to steal some information from the array projected here while I'm doing this. Our resolution, I'm going to use the same resolution because it matches the lock off, because it matches the aspect ratio and everything else of what's going on with this. So we'll set the resolution horizontal to be 350, 376 for the vertical. And then as far as the size goes, our total size is 4.61 by 4.96. And position, we could drive it here position-wise. And so that's in horizontal mode. I can switch it to be, vertical mode. I can switch it here to be horizontal. And success. Now, if we look in the feed, that's what our light map pack UV looks like, which is just interesting to play with how much less space we're using and how more optimized it is. So like I said, we could use the way that this light map is done for a projection as well and not have to worry about it. But it's nice to have those options to know the different means of how to work with it. Does that make sense? I'm going to go ahead and pull us back to here. So this is a much shorter lesson than the last few have been. Basically just kind of a exploration and a dive into some of this UV work, get a feel for it, see some of the pieces that Disguise didn't have enough time to cover in the class that they're teaching right now. So an additional resource for them. So are there any questions? While I vamp to fill time, I hope everyone's doing well. I'm also doing really well about trying to stay hydrated this entire process. Oh. Great. So viewers have been buffering a little bit. Apologies for that. Let's see. Stream health. I will always defend Blender's honor, Rob. I love that program. It's really, really clever, to be honest. And it's nice that such a powerful tool is available open source. Like I said, that's what I use. I should probably learn Cinema 4D or 3D Studio Max at some point, but I'm really happy working in Blender and it does what I need. I need to check with Disguise about distributing that the Blender file I have. I think it should be fine. I'll try and throw it into a Dropbox and post a link in this video after I make sure they're fine with me sharing it. And so that will be in the comments for this video once it goes live. I'm glad that helped, Mary. It's great to see you. Yeah, so any other questions from the group? If not, I'm going to call it a wrap and make lunch, which sounds really nice right now. And maybe try to enjoy the outside air. All right. Thank you, everyone. Have a great day. We'll be back again next week at the same time to do, like I said, I'm going to try and make the introduction to D3 from a watch out point of view and then comparison between the two, just because that's something that I've never really kind of seen well laid out. And both programs have their place. Both are very good at certain things. Watchout's auxiliary timelines are something I still dream about having in D3, for instance. But yeah, so have a good week. Thanks for stopping by, and we'll see you next time.